Hello, welcome everyone. Thanks for coming on today. Happy New Year. I hope everyone's had a really good break and a really good New Year. We are really excited to have the show today. We have a really good kickoff for the new year. We have an entire team from the company Aurora. They are a company who's building driverless trucks and driverless cars for a new fleet of automobiles in the world. We have 3 people coming on today to talk about Kubeflow, to talk about how they've operationalized Kubeflow, which is particularly exciting because people in the MLOps community are always asking about Kubeflow, always looking to see how Kubeflow really works in production, what makes it easy, what makes it hard, where are the challenges. These guys are all experts in that field. So we have 3 people coming on today. We have Vinay, we have Maurizio, and we have Ankit. Tech leads, software engineers, and staff engineers all throughout the Aurora team from SF to Pittsburgh. We are really grateful for you guys to come on today and to teach us a thing or two about Kubeflow. Welcome to the show.
Hey, how's it going?
Good. How you guys doing?
Hi.
Awesome. So I think I'm going to let you guys just kick it off because we started a few minutes late. So I want to give you guys all the time that you have. So we will let you guys share your screen, showcase what you're going to talk about, and I'll jump in if the community has any questions. Feel free to drop them in the chat. And I'll also be dropping a blog that accompanies this talk, so anybody can click on that and read through this after the show. Thanks, guys.
Cool. Hi, my name's Vinay. I'm a tech lead at Aurora, and today we're going to be talking about Kubeflow with Ankit and Maurizio, who are also my colleagues. And we're going to be talking about how we use Kubeflow here at Aurora to accelerate ML model development for autonomous vehicles. So a little bit of agenda. We're going to do an introduction. Then we're going to talk about Kubeflow Pipelines, the infrastructure, and then kind of how we adopted it at the organizational level. So a little bit about us. So Aurora's mission is to deliver the benefits of self-driving technology safely, quickly, and broadly. We build a driver which is able to operate on a vehicle from a semi-freight to a passenger vehicle. And of course, we're hiring, so you can visit our page, aurora.tech/careers. To kick us off, I'm going to quickly talk about how we actually do autonomous vehicle development. Here is what we call our data engine. And where it starts is on the left. So we have a vehicle which is driving in the real world. It's collecting data, and that data is really composed as a log. That log is basically all of what the sensors see, the decisions and actions that the vehicle made. Once the mission is complete, the vehicle log is uploaded to the log and then ingested into our cloud system. From there, we kick off a bunch of labeling systems that gets put into a label store. And then finally, this is actually where Kubeflow starts. So Kubeflow will take those labels and create data sets out of them. We will then train a model, potentially do evaluation, and then maybe even do some model export on different GPU SKUs. Our perception system is actually composed of many models. So once you train one, it then is really connected to other models and then to our planning module, which from a high level, the planning module basically decides kind of what trajectory and what actions the vehicle should take. As a perception developer, you would then actually kick off simulation once you've trained your you've trained your model using Kubeflow pipelines to verify that the vehicle is still operating as it should be or potentially operating better. And then you deploy it back to the vehicle, and then the whole cycle starts again. So this is an iterative loop. And if there's any slowdowns in any of these processes, it makes the whole entire development process go slower. We have fewer tries per quarter with new ideas and new capabilities on road. And before we had Kubeflow, we actually had a whole bunch of manual steps to train models. This was an incredibly slow process. And this is actually kind of what the genesis of why we actually decided to bring an ML orchestration system into the flow. And Ankit's actually going to speak on the pain points at Kubeflow Pipelines.
Hello, everyone. My name is Ankit. I'm a senior software engineer at Aurora. So before we get into the nitty-gritties of how we design the layer, how the components work, how the pipelines work, I just want to take some time to set up the context to see what were the pain points, what set up us on this path. So when I started working here around 2 years ago, I talked to a lot of ML engineers in the company, dive deep into the into the workflows they had already. And so there were a lot of pain points which were slowing down the development and also just making life of everyone harder. So some of the viewers in ML space who worked in a mid to large team might have seen these already in their workflows and how they can slow you down. So some of them I'm just gonna highlight some of them as the lack of automation was always the biggest one, and just you have a lot of different stages in the model workflow, and if you want to iterate fast, you just want to set experiment as soon as possible, as quickly as possible. So if you are babysitting each stage, seeing the failures and retrying, or you kind of lose a lot of time. So just getting that from to manual to automation was a big requirement for us. And just to kind of extend on that, if you are running a lot of experiments, you want to be able to track them and trace them so that you can go back and share with your team, but also see where things went wrong. And that was the other pain point we saw with our users. Finally, with the if there was no sort of unified interface where people can debug the experiment across the whole life cycle, which was a big point that we wanted to work on. And finally, the infrastructure abstraction. So ML, from the perspective of ML engineers, they don't want to get too much deep into the infrastructure and just focus on the modeling side. So this was another pain point that we saw from them. So with this, we sort of got into this space where we're trying to think how can we design our ML orchestration layer, and we wanted to have some of these principles to kind of overcome the pain points, but also to make sure that it withstands once we get to production and scale it up. So just to highlight on some of them, being able to automate, reuse, and extend the pipelines. So how easy is it to compose them, declare them, and then extend them when you're trying to build on top of it? Can you scale with data and models? And the overlooked part, how does it scale with the developers? Like once you have a large team, can you easily share between the teams as well? Then you have security, just to make sure you don't need to give too many permissions unnecessarily on every layer. Being able to easily maintain and use onboard new pipelines, new components through self-service mechanism. And finally, and actually very important one, is the reproducibility and traceability. So being able to reproduce the entire data sets, models, trace them back when things go wrong is very critical for us. And with that, we basically decided on to use as the ecosystem for our development. Kubeflow Pipelines specifically for the pipeline development of for our models. And Kubeflow as a whole is a large platform. It is a toolkit based on Kubernetes, and it has a lot of things. So pipelines is one of them, but they also have notebooks and serving and a lot of other things. So we are going to focus on the pipelines aspect in this talk, but there are a lot of other things you can do with Kubeflow, for example. So looking at the architecture of how we design our whole system, we basically had 3 layers. And the first layer was the build layer, which is responsible for building the Docker images and the artifacts needed. Then you have your Kubeflow pipelines, which is the ML orchestration layer, which is responsible for orchestrating the whole life cycle of the workflow, artifact tracking, experiment tracking, giving the UI visualizations. And then finally, the compute layer, which is responsible for handling the compute-intensive tasks. And this is the critical part of our architecture, where we separated out the compute from the orchestration of ML orchestration, so that we are able to offload compute on a lot of different systems, including like some of our homegrown systems, but also like Sagemaker from AWS. The pipeline triggers are essentially how you trigger the pipelines. So we have a few use cases that we support, and I'll talk about them in a few slides. Just to make a note, we did evaluate some other ML frameworks like MLflow, Metaflow, Airflow, when we were looking into these frameworks back in 2021. And given our history with the Kubernetes and the infrastructure expertise we have and our use cases and tooling, it made a lot of sense for us to go with Kubeflow pipelines. Now, getting into the Kubeflow pipelines and how we build the components, there are a few components that we heavily use, and some of them are common across the pipelines, across the teams, and some are more specific to the model or the team. So, for example, Batch API, Sagemaker training job, Slack integrations, and also GitHub integration. They are more common components which you'll find in more or less all of our pipelines. But there are also some custom components we built just for specific model or for our specific team. So the first one I'm going to talk about is the Batch API component. And just to set some context, Batch API is Aurora's custom batch processing system, and it can deal with a lot of workloads from like as small as 10 tasks to as many as 100,000. And we use this system to launch jobs for dataset generation and model evaluation. And each of these jobs is a custom Kubeflow component, which is based on Batch API. So it just launches the job on the compute layer to the Batch API and just waits for it to finish. And we also have a generic component, which is basically the basis to get things rolling and can be used as a basis for creating new components, which has been fairly helpful for us to get rolling. The next, this is one of the most critical components in our workflow because it does the training, and this is an open source component by AWS, and we have done some changes to it to make it more suitable for our use case. So something like just using some defaults to make it a simpler interface for people to start using in their pipelines. One important thing to note here is we do have a wrapper in our SageMaker job, which sort of passes down the training arguments through hyperparameters, and then launches the training script, which is what does the training for the model. And there's a TensorBoard component which is like integrated and can be used as a visualization step in the pipeline. So there are a lot of AWS services we use, and Maurizio will talk about it later in the slides as well. The next component I'm going to talk about is GitHub PR component, and this is an interesting component because it allows us to kind of merge together a lot of different systems, and very simply, it's an integration with GitHub pull requests. So you can, as a component in your Kubeflow pipeline, you can do something on GitHub from there. So it's as simple as launching a pull request comment, for example, or creating a pull request. So this one comments on the pull request, and if you see on the right on the screenshots, we use it as a way to sort of deploy our model and run a checklist on our landing pull request. So this has been pretty helpful and very useful in our day-to-day work. The next one is the component we have in every pipeline, and it acts as an exit handler for every Kubeflow pipeline, where you send a Slack notification to the developer. It can be with the failure message if things fail, or if just passed, like you just give the information that it has passed, and this is where you can see it. So this is definitely very important because it kind of makes things up to date for the developers. Now looking at, we have all these components, and we want to gather in a pipeline. You define the pipeline with all these different components, putting them together. However, there's still a lot more steps to go from there to actually have a working pipeline that developers can use. And the design that we use is integrated with our monolith build, and we use a Bazel as a build system in our company. And so the files that we're looking at, which are most important here, is the pipeline.py, which is the pipeline definition we have. And if you look at the right on the screenshot, you'll see we use a pipeline builder sort of factory method, which gives us this very nice interface in the terms of uh, uh, we can basically differentiate between compile time and runtime parameters. So runtime parameters are something that you cannot change when you're compiling the pipeline, and you need and those are something that which Kubeflow automatically replaces or updates on their own. However, the compile time parameters are something you can change when you're compiling the pipeline or the components. So this gives us good differentiation, because we compile our components in the pipeline every time we run them to make sure that the Docker images we are building and the dependencies we have are all up to date, as that is very critical for our users who are working in the Mono repo. We also have the test cases and the integration test as well. And these integration tests can also be launched from the pull request, which I'll discuss in a couple of slides. So as I was saying, with the developer workflow, you get a few ways to support the triggers and the people who are using these pipelines. So starting with the CLI, which is the just very common way to launch the experiments, is just from the workstation. You launch a binary which launches the Kubeflow execution, and then you can go and see what's going on there. The other one, which is which has been very popular for us, is the Kubeflow PR Comments from GitHub. Just to set a little context, when I say PR Comments, it's a terminology we use inside Aurora, where we are able to launch some pre-configured recipes from the GitHub pull request, and these are just great ways to kind of have very well-defined methods, and then it's easy to spread them across different teams without having very specific knowledge about everything. So we have these commands for Kubeflow, and they help us in getting adoption in terms of people launching the integration tests on their pull request, which makes it really easy for them to see how the code changes are affecting the whole system. Finally, we have the CI/CD, which is the daily and weekly jobs that we run to check for the health and the and just to see if there is any regressions in the developer in the model performance or anything. When you put all this together, you come up with this end-to-end pipeline. So this is for one of our perception model. We have a lot of these components: dataset generation, training, exporting, evaluation, and deployment, and then just the whole things come together with this Kubeflow pipelines model. One important thing I want to highlight is the unified UI. So with Kubeflow pipelines, you get everything on the same UI, so you can debug much more easily. You get all the metadata in the same place. It's easy to trace back and also reproduce. So this was one of the pain points I discussed earlier, and it's something that our developers really appreciate with this. Just to kind of go over the benefits, I think I talked about some of them already, but just to very quickly go over, we got the automation that we talked about with the different steps of the ML lifecycle. We even have a model which is basically landing twice every month, pretty much on its own. And the collaboration aspect, as I already talked about, lineage tracing with the whole metadata and everything under the same umbrella. And finally, the abstraction for the cloud infrastructure, which allows both the ML engineers to not worry about infrastructure, but also infrastructure engineers to run the autonomy pipelines without deep knowledge of it. For the next slide, I'm going to hand it over to Maurizio, who's going to talk about more how the infrastructure we built for this whole thing. And to you.
Again, my name is Maurizio Vitale, and I'll be talking about the infrastructure aspect of our deployments. And in particular, we will see what changes we've made to the default Kubeflow deployment in order to make Kubeflow a better citizen in our cloud infrastructure. Our infrastructure evolved over time. We didn't have the entire Kubeflow available at once, and we moved from left to right in the slide. We started with local deployments for just getting a proof of concept and understanding whether Kubeflow was even useful to us. And then we moved, increasing the scale and the number of users we were able to support going towards the right. For the local deployment, Kubeflow can run locally. It still requires a Kubernetes cluster, and this can be achieved by using different tools. Minikube, Kind, other tools are available. Sorry, can we go back to the previous slide? Okay. So the local deployment still requires a Kubernetes cluster for running, and this can be achieved in different ways. For Aurora, this was done initially with Minikube, and later we moved to Kind to better track what upstream uses for their end-to-end test. The standalone pipeline was a brief period of time, a couple of months, just to allow us to move into the cloud. And the cloud for us means AWS, and Kubernetes for us in the cloud means the managed Kubernetes offer from AWS, so EKS. This was very short-lived, but allowed us to do the basic work for moving really into the cloud. When we added the Jupyter notebooks, we knew we needed to do some more in order to support multiple teams and multiple users. And we will see what kind of challenges this presented. Next slide, please. Okay, well, a couple of brief observations still on the single user local deployment. This was very useful for us for validating all the manifest and the Kubeflow deployment, and is still useful for that purpose to us. And we also make use of it for validating a move to different versions of Kubernetes, but is not totally usable for real pipelines. So we dropped that support because it required too many manual intervention for setting credentials and giving access to Kubernetes resources. So for production, we really moved to a multi-user environment. And here, as in any other of our deployments, we deploy a subset of the upstream manifest. For the moment, we offer to people Kubeflow Pipelines and Kubeflow Jupyter Notebooks. And we are looking in Knative as a next step to extend our offer. The important piece of this multi-user deployment is that we wanted to integrate with other pieces of our infrastructure. So we move things that in the default Kubeflow are inside the distribution and run inside the cluster to external services. In particular, we wanted to have a completely separate maintenance schedule for the Kubernetes cluster, and in our case is even different teams supporting that. And we also want to rely on separate services for storage of assets. So artifacts are stored in S3 for us. We don't make use of the min.io that comes with Kubeflow. We want to integrate with our cloud authentication and authorization system. And we need secret management for production at scale, and that also is kept outside of the cluster. The goal is to have a minimal need for setup for each individual user. In our case is 0 setup for users. As soon as people are hired by Aurora and are part of a team, they are able to just do the work their team is supposed to do with Kubeflow. And we want to limit the support needed for the infrastructure in general. So let's start seeing what type of changes we made to the infrastructure in the next slide. The first thing we moved out of the cluster is databases. Kubeflow uses a number of them. The pipeline subsystem use a database, and Katib will eventually use a separate one, and other pieces are also in the same situation. The reason for moving databases outside is that we want to have the state as much as possible outside of the cluster in such a way that we can do maintenance of the cluster without having to worry about preserving the state. And also, having databases outside as a managed service from AWS allow us not to deal with the problems of reliability, availability, and as such, they are out of the box coming with the offer. So database is the first thing. And the only work we have to do really here is having credentials and granting access to those external databases. And that was about it. The next problem we have to solve is the authentication and authorization problem. Kubeflow and Kubeflow basically is a Kubernetes self-contained set of applications, and it uses service account in order to control access to different resources. In our case, because we want to have access to external resources, we have to use what AWS has as identity and access management, so IAM. For the pipeline and the notebook portion, we were able to use the AWS service that allow to bind service accounts to IAM roles, and that makes access easy and possible and easy. On the Kubeflow infrastructure side, we have to do things a bit differently. There is work undergoing upstream for having the same system that we use for pipelines and notebooks available. But right now we have credentials hard-coded basically in our vault for giving access. The difference between the two approaches is by using IAM roles, we have short-lived tokens that we can revoke anytime something changes in the team distribution or for any other reason we need to revoke things, while the credentials and database passwords, etc., that we have stored in the vault are basically timeless. They are valid forever, and revoking them means revoking them for everybody, which is not ideal. So talking about secrets, again, this is another piece that we moved outside of the cluster. We make use of a vault, an HashiCorp vault, and the access to it is, again, different for pipelines and notebooks, different from what happens in the Kubeflow infrastructure itself. For pipeline and notebooks, we have full control, so we are actually using a vault injector that basically renders a file containing the secrets inside the pod, and is the only piece that needs credentials for the vault itself. On the Kubeflow infrastructure side of things, we have moved to use CSI, which is the container storage interface, and in particular a vault provider for it. And what this does is to produce a secret that then can be mounted inside each application, and more important, allows us to populate the environment, which is environment variables is the way Kubeflow applications are configured, from the content of the secret, and allowing this secret information to be available to applications. And we use this everywhere for database credentials and everything else secret that applications need. Another piece is storage for artifacts. Everything which is either an input or an output for Kubeflow tasks for us resides in S3 buckets. We don't make use of the internal MinIO subsystem. We directly use the real thing. We have access to S3, and that's where we put things. Access is where basically buckets come from the team, so everybody will maintain their own buckets with whatever lifetime they want to give to artifacts, and maintain credentials for getting access to those buckets. yeah, that's about it. But again, is a part of the goal of keeping state outside of the cluster, because this is a huge help in maintaining the infrastructure working. Now, another point of interest is how we allow access to Kubeflow from all the users that need to have access to, and only those. We don't use the internal, again, is another place where we don't use the internal Kubeflow solution, so we don't use DEX, and we integrate with our own cloud authentication and authorization system. At the moment, this means we have multiple layers of proxies, and before getting to the history ingress, that is what Kubeflow uses. And this is because we need to map the headers that our corporate cloud-based identity provider provides. Those needs to be mapped to what Kubeflow needs to authenticate users. But this is transparent. Users don't have to do anything as long as they have credentials for getting through our Okta-based system. They are able to get to the dashboard or trigger pipelines in another way. The last piece is we haven't really gone in detailing for this part, but we don't follow the normal Kubeflow model of one namespace per user, because that would be too much maintenance burden for us. We have one workspace per team, and then we need to find a way to allow multiple people to be part of that team and get access to pipelines and notebooks. The way we do this is by extending a bit the mechanism that Kubeflow uses. The default Kubeflow uses cluster roles, Kubernetes cluster roles in each namespace for granting access. We made modifications to allow multiple people to be part, to be subject in that role and being able to assume the role. And we furthermore have a system that synchronize corporate information from outside the cluster and make modifications to this cluster role and to Istio rules for allowing the access that are supposed to be allowed. This part we haven't upstreamed it yet, but is available in our public repository. And the last piece that is important for us for making Kubeflow a real product we can use across the entire organization is high availability. And this has two aspects. One is maintaining the service available for people. And the other part is allowing us to do maintenance work without affecting the work. In order to achieve this, a part of the puzzle, we already discussed it. We moved many things outside of the cluster, and thus they are not a problem anymore. AWS guarantees that databases are available. They are multi-zone, so they are failure-proof. Inside the cluster, we did changes. So our Istio system has an autoscaler and minimum replicas of 2, which means something is always available no matter what happens. Well, to some extent, no matter what happens. For the Kubeflow components proper, we also added replicas. We have multiple instances for each pod, and we have a pod destruction budget that allows us to remove nodes when needed for maintenance without affecting the availability of the service. This is also something we plan to open source, but we haven't done it yet. We have the internal repository for manifest now. That said, I give back the word to Vinay for some conclusions.
So as we had staged building out pipelines and developing the infrastructure for Kubeflow, we learned a whole bunch of things. On the pipeline side, we realized that internally as a larger organization, we had to actually pitch teams about Kubeflow. People did not know much about it, and they also didn't necessarily understand what it would be used for. So when we pitched them, we had to highlight use cases and the benefits so that we could actually get teams to prioritize building automation. Automation actually is also not necessarily the first thing that teams think about when they're thinking about what they want to work on for a given quarter. they're mostly prioritizing features and, potentially product-focused features. And the way to actually kind of switch them into thinking the need for automation is to provide demos and showcases. And that kind of really foments and gets people excited to actually start building, and then being able to deploy those and start using them instead of manual steps. And as we started working with teams, we found that the fastest way to actually get them to have a pipeline and to start using the infrastructure was white glove service. We would build the pipelines for them. And then we are now switching to a model where we're doing more consultative work, where we help ML engineers build those pipelines. And we want to keep a pretty tight loop with those engineers, primarily because we want to give them kind of the best guidelines and guardrails to getting a pipeline working. One of them is to actually build a pipeline in small increments. Basically, start with 2 steps, then go to 3, etc. This enables them to see the benefit of the pipeline, get more feedback. Not only that, a lot of the times that when we were building pipelines, ML engineers would say, I'm not sure how we could represent step X in the pipeline. It's more of a judgment call. But as they build the pipeline, see it run, they actually figure out how to actually create that judgment call into some type of step that can be directly integrated. As we work with customers internally, we're able to actually invest into common componentry. And look, end goal is that if most of our services have some kind of Kubeflow component, that means that the next pipeline we build is less work than the previous one. And as we've worked through this, we've actually been pretty keen on tracking metrics, primarily because we are making a relatively large investment, both in terms of time for building the pipelines and infrastructure. In terms of the pipeline runs, we started this journey in actually 2021, and really by the time at the end of the year, 2021, and then in 2022, we had been released multiple pipelines to teams. And we've seen a significant, slow growth and then a huge jump of runs in the summertime. That was because a bunch of interns were there just retrying a bunch of stuff. But fundamentally, we have hundreds of runs per month. And this correlates pretty well to a single ML engineer potentially running 5 pipelines a week. Given that our training pipelines takes multiple days, it gives us really good signal that each of these ML engineers are running all of their experiments using Kubeflow, and they're running about 5 of them a week, which is kind of makes sense with how much work they could actually track and to see which of their experiments actually is going to make it to be able to deploy. And then the final one we've been tracking is the number of pull requests that we are verifying. So as Ankit had shown, we use Kubeflow pipeline commands inside of PRs, and we've seen a significant growth in this, both from ML engineers and also from infrastructure engineers trying and doing integration tests. So that's the end of our slides. I'm more than happy to answer any questions. I guess back to you, Ben.
Awesome. Thanks so much. That was a fantastic presentation. Thank you guys so much for taking the time. We do have a bunch of questions actually for you. The first one is, I think, for Maurizio, based on just what he was talking about with MinIO. I actually didn't realize that Kubeflow by default came with MinIO as the backend storage. Was the main reason that you guys opted out of it just security, or was there also like performance concerns or scalability concerns around it?
The main reason is keeping the state outside of the cluster as much as possible, and having a reliable backend storage without having to think about it, but mainly having it out of the cluster, because if you keep state inside the cluster, every time you do any move, you have to at least think about what happens to the state, save it somewhere, and recover it. So the more you can put the state outside of the cluster, the easier maintenance of the infrastructure becomes.
Yeah.
This was also a strategic choice as well, because MinIO actually has gone to an AGPL license, and we can't use that at the company. So yeah, we are somewhat protected. Yes, there is still some client code that's under AGPL in the latest version. The Kubeflow upstream Kubeflow community is working through it, but we're mostly protected against it. Like as Maurizio said, we don't have to plan a massive migration. We're just hoping that the community can move to a different client that allows the same proxying thing, and that avoids getting into this AGPL problem for us.
Yeah, that makes a lot of sense. We actually had a really similar situation on our end too. I think wouldn't be surprised if a lot of people had similar situations from a compliance perspective. Cool. So on as it relates to Kubeflow, like specifically or more generally as a tool, what were the other main competitors that you were considering, if there were any, for the team?
Yeah, so when we started evaluating back in 2021, I think the space was up and coming. So it wasn't as you see now where you have like hundreds of tools available right now. It's just like hard to choose. But at that time, there were still a few big competitors. I would say like Airflow, Metaflow. I think Metaflow was still a part of Netflix back then, and now they have open source a lot of things. But Airflow, Metaflow, MLflow, which was more on experiment tracking side by Databricks. So these were like the main competitors we were looking at evaluating, and I think all of them are actually pretty good. And it really boils down to what exactly use cases you have, what expertise you have in-house already, where do you actually need to support. And so for us, we had a really good infrastructure expertise in Kubernetes. We already had a bunch of clusters we maintain. So it was easy to get started with Kubeflow because it's kind of the whole idea behind it. And all the features that we were looking for, like Kubeflow had them in terms of UI, experiment tracking, artifact tracking. And since it was open source, like it's easy to kind of go ahead and add things, which wasn't always possible for some other competitors as well, because their mission might be a little different than, just having something for machine learning related work, but they might be more generic. So this
Right.
is a good perspective.
Have you guys considered, like with the advent of all the new tools that are doing things, have you guys considered other ones, or are you guys very like steeped in and happy with your Kubeflow choice?
Yeah, I would say we're pretty happy with it right now. And we keep an eye on like other tools, upcoming tools in different parts of the domain. Like I recently last year went to the summit, Ray Summit, which was by Anyscale, and they are doing a lot of work on the compute side. Like how do you do that more efficiently? So I would say like we keep an eye on the new upcoming tools, but right now we're pretty happy with the ML orchestration with Kubeflow pipelines.
Cool. Somebody asked if you guys had looked from the audience had asked if you have looked at TFX Tensorflow. I think Tensorflow Serving, right?
Yeah, we actually don't use TensorFlow Serving because we have a kind of unique use case where we're not actually really running models live internally, because the primary compute for our quote unquote customer is on vehicle. It's a physical hardware device, right? It's a car or truck. So we don't use it. And then B, the other aspect is when we're running simulation and evaluation, most of the model inference tools require a lot of config to get a model running, in the sense that you maybe put up a Kubernetes manifest for this specific model. We actually have it by commit. So each PR may have actually a different set of models because someone may have retrained stuff. So we're not going to stand up infrastructure for every single PR because that might put burden on the ML engineers. Instead, we just basically do it through we basically just, in essence, we simulate our vehicle by using our vehicle software.
Got it. Cool. Changing a little bit, we have a question from Keith in the chat. If you needed to track each database access back to an individual user that ran it, how would you go about doing that? It says, if I understood right, the notebooks are all under one IAM role and using either shared secrets or IAM generated temp secrets. So how do you differentiate between individual users?
So there is some level of individual user tracking because each Kubeflow user request has their email. We do know who is making requests to a notebook. And basically we do say each one notebook when it's created has someone's name. It's a very loose way of kind of understanding who created the notebook. Obviously, because it's a shared namespace, we have a high trust, in essence, high trust here within a single team. So we don't pass on that information deeper through the role. That's not something we currently do. It's something we've been thinking about. As we especially move, because we're, from the notebooks access our data lake, and we actually have ACLs there for certain data sets. So that's something that we are planning to think about and figuring out. It's kind of a challenge when Kubeflow's abstractions are very rich for groups. This is something that upstream that there's been a lot of discussion because it's been a pretty big issue for enterprise customers. You can't have one user, one silo, and manually let people share to whoever they want, because that's the default way of Kubeflow sharing. And it's a lot of manual work and provides very little continuity. That's why we came up with this group thing with the namespace. We still need to refine this, and I hope we get more support upstream.
Interesting. Yeah, that was actually, I have two like split follow-ups from that. One is as it relates to like support upstream and conversations with the Kubeflow maintainers. Do you guys contribute back to the open source Kubeflow? Are you involved with those high level discussions of direction, or have you guys forked Kubeflow and are kind of on your own journey with it?
We're actually doing both. We actually forked. We have open forks. We have not yet committed our PRs haven't landed upstream yet. That is something that we still need to work on, but we are actively in discussions. We, basically contribute on GitHub issues, on Slack, and basically tell them what we need, what we're doing. We show them PRs. We still haven't done the work of getting our PRs from our open fork to the upstream, but that's something we're prioritizing this year.
That's always a lot of work to get your stuff back into an open source community to align those values. It's always tough.
Yeah, I think it's more or less about that. It's just that, we're a pretty lean team, and just even keeping basically the maintenance work of pulling everything in, doing the merge commits, deploying everything, making sure we don't break stuff. And then it's like, hey, do we actually have time right now to like also go, once we do the merge, to go back up? And we haven't put enough effort on that area. And I think that's a real focus area for me to get the team to kind of align around this year.
Yeah, that's super cool. We have actually two more follow-ups on the chat. One question, have you tried Sagemaker? Have you tried any of the Sagemaker components of Kubeflow? Do you know if that operator is stable to use? If you're not, I'm not sure if you said you weren't deploying models, but.
So Sagemaker, so what we use Sagemaker for is essentially training.
Okay.
We do use Sagemaker for exporting as well, but it's the same component that we use. So the component that we have been using is the open source one by AWS, and we have sort of a wrapper that kind of uses some defaults over that, but it's been pretty stable in our experience. Like, we have been using it for more than a year, and like we haven't had any large issues with that. You always like, sometimes you get like, there's not enough machines. Sometimes you see that issues come up, but we usually get like very good availability with the machines and the performance there.
Awesome. Yeah, that's great to hear. Cool. Actually, my next question and the community's next question was very similar. Chris is asking about the Kubeflow pipeline syntax, if it's easy to pick up for ML engineers, how much work it was for them to like learn it in the first place, if that kind of hindered adoption. And my follow-up was going to be like, from when you started to at this point, how long does it take for an ML engineer to actually write their own Kubeflow pipeline?
Yeah, so I think I'll start, and Vinay, you can help me out with that as well. So like to the first question, like I feel like the domain specific language that Kubeflow introduces, since it's pretty much all Python. So as long as you are familiar with Python, which most of the ML engineers are, it's really easy to pick up. There are some like specific things about Kubeflow pipelines, just like some terminology in terms of how you execute pipeline, or what are the pipeline parameters, how are they different from other things, how do you manage the Docker images. So there are some opportunities in terms of like just abstracting some of that, and that's essentially what we did, like with our internal tooling and infrastructure. That a lot of that gets abstracted as we saw in the slides. So that helps engineers to kind of just like go ahead, write their own components from. They have the boilerplate to go ahead with that. And then just like make it very easy to write pipelines. So I would say like since we started, we have seen the time frame where engineers pick up and write their own pipelines to get shorter and shorter, because we keep building more tooling documentation on top of it. So like I would say like the first user we had took a few months to kind of get around this, but nowadays we see like new users come on board, and within weeks they start writing their own pipelines. So it's been a lot more faster now.
That's really cool. That's an awesome contribution to make that abstraction lower. I guess I was going to ask how how you guys would recommend somebody starting fresh with no kind of Kubeflow experience, how they would get started. I mean, you guys have built all these abstractions, but if you didn't have them and you were new and wanted to maybe bring this up in your company, do you have any recommendations for places to go, things to look at?
I think starting with Kubeflow docs is the best place. And going through the tutorial, I think it does take someone to grasp the tutorial. What I mean there is that the tutorial is not like the tutorial and the information they provide, the examples is not like necessarily straightforward to understand. And the copy paste ability of it is a little bit low, but once you can have one person kind of work through it in a week and a half, maybe in like a local setting, I highly recommend just making a code lab so that it's like copy pasteable for the next person. So you have that boilerplate, and that's like to me, that's been like the biggest shift and transition is like, we have to have supplemental material that is in addition to the Kubeflow docs, because otherwise I don't think that it's possible for someone to be able to make a pipeline in a day or two.
That's super
interesting. Still not here in the open source world, like, unfortunately, but yeah, if you have one person who's the beachhead and then they can make something the next person could copy paste, I think you're in a really good spot.
That's interesting. So you need one brave soul to really push through, document their experience, and then share that across the team. And as you go, just continue to add that up and build on that. So document your steps is what you guys are saying.
Yep.
Really cool.
Just to add to that, I would say like there are some upcoming like initiatives, like I think Aricto has one where you get like managed Kubeflow. That for them, you just like go on to their website and just like start building. So I think there are some opportunities like that, but that might be for like if you are like a smaller team maybe and trying to just like get started really quickly.
Well, interesting.
There's another opportunity too, depending on where, if you don't really have a cloud or you can pick whatever you want. Google Cloud lets you actually run the Kubeflow pipeline DSL directly. It's called Vertex. And you can basically just take your pipeline and then just write it in Python, and you don't have to set anything up, and you just send it to Google or to Vertex, and it'll run it fully. And it'll run it using their trading as a service, blah, 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 and all the other stuff. They'll manage the Kubernetes under this hood and get some components. That's actually a really super easy way to get started.
Would you guys consider using that managed service, or do you think that what you've built is more useful for you?
I think actually for us, we were on AWS, so we can't really use Google Cloud services. So we're pretty much, we're kind of sticking with this. I will say that the ease of using Kubeflow on AWS has gotten a lot better too. They actually have now owned a distribution, so you can just kind of follow their 4 or 5 steps and just install, and it kind of makes you use certain services, but it's like a couple of steps, and you install it onto a Kubernetes EKS cluster, plus all the things. So the barrier to entry of getting Kubeflow on AWS is pretty low, and it's now fully supported by them.
That's really cool. I mean, that makes a lot of sense because they do the same thing with Airflow. And I feel like Airflow is a very, very good option for them to kind of fully manage, use S3, use IAM permissions.
I will say that they don't actually provide a managed Kubeflow. What they provide is basically the recipe and the instructions, and then they maintain componentry basically for the integration to work right. The installation to work well. And I think the other part is they're also contributing to make Kubeflow work better on AWS.
Got it. Okay, that makes a lot of sense. So I think we're just out of time, but I have one more question. I think it should be pretty quick. You've been talking a lot about like deploying your service to teams across the organization. Is it one large like Kubeflow pipeline service that you guys have that you create new users and permissions for every new team, or do you deploy an instance of your Kubeflow to that team for them?
Yeah, we have a single cluster for Kubeflow, so all the teams are namespaces inside that one cluster, and we have a separate cluster for development, but that's separate from users. So users don't really have to do anything. We have to do some minor work per team, but those don't come up very often. And then users are just onboarded automatically, but they share the same Kubeflow cluster.
Got it. That makes a lot of sense. That's very cool. Well, I mean, you guys have built a phenomenal piece of technology around Kubeflow. It's really cool to see. Thank you for sharing it with the community. Thanks for coming on and giving us your time. I really appreciate it.
Cool. Thank you. Appreciate you having us on.
Absolutely. All right. Thanks everyone for coming.